So molarity. Molarity is a way we describe the concentration or the strength of a solution. So a simple definition for molarity is the concentration of a solution. Now, it really would be the concentration of a solute dissolved in a solvent to create a solution, but we're just going to keep it simple. So molarity is the concentration of a solution. Or a better definition would be the number of moles per liter volume. Two key things to note is it's in moles and it is in liters. So if you have mass, you got to convert it to moles. If you have anything other than liters, you need to convert it to liters. So molarity has a nice, neat little formula. That's going to be molarity is equal to the moles divided by the volume. Big M being molarity. And it is measured in molar. You might also see it moles per liter. N is moles. And that's measured, of course, in moles. So if you have grams, like I said, you got to do a mole conversion. V is volume. It is going to be measured in liters. So if you have milliliters, you need to convert it. But molarity is pretty simple. It's just the moles per volume. Let's draw a little illustration of molarity to help visualize what molarity actually is. So we got us a little beaker, and in that beaker we got some water. So in your beaker of water, you got your water molecules. We'll put about 10 in here. Now these are not to scale, or are they in the correct form, in the correct structure, but we're not worrying about that right now. We just need a representation. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so our blue dots will be our water, and we're going to add some salt to our solution. So our yellow dot will be our salt, and again, these are not to scale nor an accurate structure. We're just going to use dots, keep it simple. So we pour just a small amount of salt into our solution and add just a few molecules. Well, the salt in comparison to the water molecules isn't very high. We got 10 molecules of water, we got 3 molecules of salt, so we could say that concentration or that molarity is kind of weak. Then if we pour a little bit more salt into it, we'll keep it at 5, and we got 10 water now we got 10 water molecules to our 5 salt molecules. Now the solution is Now the concentration is a little bit stronger. The salt molecules are half the amount of the water molecules. Then if we add some more even, make it even more concentrated, or a higher molarity, those salt molecules are almost equal to the water molecules. So in a nutshell, that is molarity. The more molecules of your solute, or what's dissolved in your solution, the higher that concentration is going to be, the higher that molarity is going to be. And the fewer the molecules, or the fewer the moles, the weaker or the less concentrated or less molar it'll be. But the way you're usually going to see molarity will, of course, be in a problem form. So let's take a look at those. So just like any other chemistry problem, you need to pick out your information and then see what you can do with it. So let's look at the first problem. So if 20 grams of ammonium chloride is dissolved in water to make 750 milliliters of solution, what will be the molarity? Alright, so let's pick out some information. I got 20 grams of ammonium chloride. That is a mass. And it's dissolved in water to make 750 milliliters of solution. So I got a volume of 750 milliliters. What will be the molarity? So I'm looking for molarity. Now, if you remember, our molarity formula is moles over volume. I don't have moles. I do have a volume, but I don't have moles. I can figure out moles, though. I got a mass. If I got mass, I can convert to moles. So let's do that. So I got 20 grams of NH4Cl. I need to convert that to moles of NH4Cl. So I need my periodic table. I'm going to look for the molar masses of these compounds, and I'm going to round my atomic mass number to the nearest whole number. So chlorine's 35, nitrogen's 14, and there's 4 hydrogens, so that's another 4 grams. 35 plus 14 plus 4 is 53 grams. So 1 mole of NH4Cl is going to be 53 grams of it. Grams cancels out. So 20 times 1 divided by 53 says I got 0.38 moles. 0.38 moles of NH4Cl. Now that I got moles, I can stick that into my formula. So molarity is what I'm looking for. So that's going to be X equals moles, which is 0.38 over volume. Now my volume is in milliliters. I need it to be in liters because molarity is measured in liters. So I'm going to change milliliters to liters by moving this decimal 3 times to the left. So 750 milliliters is 0.75 liters. So 0.75 goes on bottom. So I got 0.38 divided by 0.75. So I get 0.503. But 0.503 what? Got to have some units. Now molarity is measured in moles per liter or molar. So I could do big M to represent molar, or I could do moles per liter to represent the same thing. Your choice, really. But anyway, either way, there is our answer. Let's look at another one. Calculate the concentration of a solution prepared by dissolving 24.5 grams of silver nitrate in enough water to make 2.5 liters of solution. So let's pick out our information. So I got 24.5 grams. Well, that's a mass. And we know we have to have moles. So I have to convert this. Then we got 2.5 liters of solution, so that's a volume. Now our formula again is molarity equals moles over volume. And I'm looking for concentration. Concentration is molarity. First thing we got to do is convert this mass to moles. I got 24.5 grams silver nitrate. Convert that to moles of silver nitrate. So 1 mole of AgNO3 is how many grams? Well, let's use our periodic table and add that up. So silver is 108, nitrogen is 14, oxygen is 16, and there are 3 of them. So I add that up and I get 170 grams of silver nitrate cancel. So 24.5 divided by 170, I get 0.14. So I got 0.14 moles silver nitrate. Now we can use our formula. So I'm looking for molarity, that's going to be X. Moles we just found out to be 0.14. Volume is 2.5 and it is in liters, so I don't have to convert anything, so that's just 2.5. So 0.14 divided by 2.5, and I get 0.058. 0.058 what? Well, that's going to be moles per liter, or you could also do molar. And there is our answer. Let's look at another one. So how many moles of calcium chloride are required to prepare 2 liters of 0.7 molar calcium chloride? So it says how many moles? So I'm looking for moles of calcium chloride are required to prepare 2 liters. So my volume is 2 liters of 0.7 molar calcium chloride. So my molarity is 0.7 calcium chloride. Now this one's pretty straightforward. Doesn't look like we need to convert anything. So molarity equals moles over volume. My molarity is 0.7. Moles is what I'm looking for. Volume is 2. Put this over 1, cross multiply. 1 times x is 1x. 0.7 times 2 is 1.4. Divide by the value with x, that cancels. X equals 1.4. But 1.4 what? We're looking for moles, so this is moles. We need 1.4 moles to produce that concentration at that volume. And let's do one more. It says what mass in grams? So I'm looking for a mass in grams of sodium will be required to prepare a 2 molar solution in 500 milliliters. So my molarity is 2 and my volume is 500 milliliters. I already know this volume has to be in liters, so I'm going to change that to liters, move this decimal 3 times. My volume is 0.5 liters. Alright, so I got a molarity, I got a volume. With that, I can solve for moles. It's because molarity equals moles over volume. My molarity, we said, was 2. Moles is x. Volume is 0.5. Stick 2 over 1. Cross multiply. 1 times x is 1x. 2 times 0.5 is 1.0. Divide by the value with x. 1 cancels. X equals 1.0 moles of sodium. But we're not looking for moles. We're looking for grams. So we got to do a mole conversion of sodium. So 1.0 moles of sodium, and I'll change that to grams. So 1 mole of sodium is how many grams? Well, the atomic mass number is 23. So 23 grams is 1 mole. Moles of sodium cancel. 1 times 23 divided by 1 is 23 grams. So we need 23 grams of sodium to produce the molarity at that volume. And that is pretty much it for molarity. Just make sure you watch your volume, make sure it's in liters, make sure you convert grams or mass to moles, and just plug into your formula. It's pretty straightforward, pretty simple, but everything else, make sure you practice. And I hope this video helps. As always, good luck on your tests.